Hi folks, good afternoon, good evening, good morning, wherever you are. Welcome to our webinar about functional safety according ISO 26262, which means how we understand functional safety in the automobile industry, which basically means for passenger cars. So just to introduce myself, I'm Arnulf Braatz from Vector Consulting Services. I'm one of a few safety experts here at Vector, so I'm leading the team of safety experts at Vector, but I'm not the only one here. So next to me there's my colleague Andreas Horn. He is today again responsible for the question and answer. So just to remind you, it's not just that we present you an overview about how functional safety is understood according to ISO 26262 and how we apply it in the industry, what are kind of best practices. We also want to provide you the opportunity to ask some questions. So in your WebEx window there is a question and answer section where you can place your question. So it's just you seeing that question, and then of course we here on our side and you get an answer as soon as possible. Of course, if it's just a few questions, then of course you get your answer very quickly. If we get a few more questions, then typically you have to wait a bit for the answer. So stay tuned also until the end of this presentation, maybe also a few minutes afterwards. We will stay here as long as there are people in waiting for their answers, and we will provide you as good as we can, of course, by just a chat window. We try to provide you as good as we can answers to your questions. So feel free, if you think something is not clear to you, and then just ask us. Okay. So far, not to forget that, of course. Somewhere in between in this presentation, we will take some time for summarizing some of the questions. So, of course, don't be concerned. We don't name your names. Just the most often asked questions will be somehow emphasized here, in just to let other people know, assuming that the same question is maybe around also for other people who have not asked the question. We will give you the answer also for the audience. 2, 3, 4 representative questions. Of course, not all of them will be then answered again somehow for the audience. Okay, but first of all, it's about to show you by the presentation what is about functional safety in the light of ISO 26262. So before we go into this, a few words to Vector. If you don't know, Vector is, as you see on this slide, a comparable big company. Meanwhile, it's a company which is developing tools and embedded software for the automobile industry. You see on the sites here we have worldwide. And Vector Consulting Services, where we are coming from, is a part of the Vector company. So we are a separated company, but we are 100% owned by Vector. Around 20 consultants are there, not only dealing with functional safety, but as I said already, 5 of us. They have their main business in functional safety. There are, of course, other topics which needs consultant supports like ASPICE, agile, security. So just to name a few other topics we are working on. I named already a few of our topics here, a bit more detailed. The picture from beginning of this year. So every year we ask our customers, so what are the midterm and short-term challenges you see for your company? And we gather all the answers, and that's somehow the result of the last survey we did. And you see some, let's say 3 topics form kind of triangle here. So the all-time high, short-term as midterm, is the safety and security topic. But to be honest, safety and security are always, in automobile industry, they are always named together, but they are 2 different topics. But today we are in a situation that those people who are dealing with safety are the same people who have also some concerns concerning security, because from the concept point of view and from the engineering point of view, they are very, very close to each other, security and safety. Of course, there are some significant differences, of course, but from the skills point of view, so safety engineers today in the automobile industry, they are also, if they are using some security-related devices, they are also affected by security. So that's the reason why we always name safety and security together in automobile industry. There are 2 topics, but from the challenge point of view, they are seen as one big topic because comparable methods have to be applied, comparable skills are needed. So that makes that as a kind of that topic a kind of combination out of two topics. So that is the all-time high concerning challenges. Then there's always on in short term and in midterm the efficiency. So whatever we do in the automobile industry, whatever we engineer, always efficiency is a point in concerning methods and tools, how we can do our work more quickly or more effective, whatever forms the efficiency. And somehow by security is already clear that connectivity is the technical side of security, because connectivity and also what we call the digital transformation is a topic in the automobile industry meanwhile. So security comes in on both sides, on the IT organizational side and also on the vehicle side. So then, of course, there are still other topics around which are always there, but they have not that significant. They had not been named so often in our survey. So again, it's efficiency, connectivity, safety, and security. And that's, of course, therefore our main business currently. So enough about what Vector doing and Vector Consulting is doing. So let's jump into the content of functional safety. So challenges and concepts first. Of course, one generic concept. Maybe I was too quick. So this situation is very much known. It's not so new. You see it by the timeline below. So since the late 1970s, we talk about that complexity of features in the car, which typically means electronics and software features. So most new features since the 1970s are provided by electronics and not by mechanics. So the complexity is growing, of course, because we are, as customers, we are demanding that. So we want to have more and more electronics and software in our car. It started in the very beginning with motor management systems, and it continued with safety ECUs like braking, supporting braking, stability control, anti-block system, whatever. So classical safety systems, and it went on to more comfort functionalities like head-up displays or whatever takes place on the infotainment side, and it is still growing. So complexity is not stopping growing. It's not stopping here. So the growing continues into the direction of ADAS systems, so the advanced driver systems, and somehow the level 3 of automation. And of course, we already have started to think about level 5, so autonomous driving cars. That's the key word behind. So it seems that complexity is growing in cars, and all the stuff is made out of electronics and software, for sure. So okay, that's fine, that's great. So we like that as a customer, but for the automobile industry, for the OEMs, and for all the suppliers, that means we have to master this growing complexity year by year. And what we see since years or decades, that the competencies, the skills on the suppliers, OEM side, at company side, they cannot grow so fast because people are occupied by daily business. So you cannot learn new tools, new methods by the way, right? So that's limited. So that means growing of competencies, of skills is always below the growing of complexity. So the rate cannot be aligned with the complexity growing. That's basically not an issue as far you are good enough, let's say, to master the daily complexity. But you see by this picture, that's a basic experience over years, that the distance between complexity and competencies is also growing. So there's a point in time where we have no chance, also no chance to master our daily business, because we are dealing with very complex systems, and maybe we are not prepared as a company for that. That is a general statement, but it's also true for safety, right? So that's one of the reasons why we talk about safety, because the industry found out, electronics is basically not only safety related, but is also safety related, electronics and software. And if you cannot master that growing complexity in terms of growing software and growing functions on an ECU, that means that we get safety issues more probable on our cars, and that could threat people's life. And that is something we cannot accept, right? So that's why functional safety as one aspect of mastering complexity came in. So what is functional safety about? So very simple picture here. It is about what kind of additional risk by faults can be introduced by electronics and software, which could then harm people, right? So if we talk about functional safety, we talk always about faults. That's unfortunately the unhappy side of that part of engineering. So we don't talk about the fascinating new functionality. We talk about what could go wrong by that functionality and what would that mean to people who are in the car or around the car. So if my ESP is working well, everything is fine. But if my ESP, my stability program on the car, does something wrong, breaks one wheel, then my car gets unstable and crashes into a tree, maybe. Or my electronic brakes, parking brake is getting loose and my car is rolling down the hill and hits into a person or whatever. So these are cases considered by functional safety caused by electronics and software, not by mechanics. That's outside the scope of functional safety. So it's all about to limit, of course, everybody who's an engineer knows you cannot avoid 100% faults in electronics and software, but you can limit the probability of that the fault occurs in the car, and that means to reduce the risk to somehow a kind of acceptable level. And that is all about, of course, liability, right? Product liability. So that's a general rule, not only for functional safety, or since we have functional safety in place, it's a general thing for everybody who is developing cars since we have cars, let's say, right? That we are in charge to limit the risk for people who are using cars. So, but since we have the ISO 26262, we have a very clear standard for that, what is accepted as a risk, and that is expressed by many, many, many requirements for the process and for the product itself. And you see by this picture, so nearly everything, or it is every phase, every activity along our V development cycle is affected by functional safety. It starts on the left side with requirements on system level, and it ends up on the right side by system testing, verification, and validation. All these activities engineers are doing to develop electronic components together with software, they are affected by functional safety. That means affected by the ISO 26262. And also, in addition, all the management activities like project management, configuration management, all these are affected by functional safety. You see that is a life cycle-based approach. It's not just focus on testing or focus on requirement. It goes across everything we do in development, more or less, right? There are areas more affected than others. That's true. So management in general is less affected than the engineering disciplines. Makes sense because whatever makes a car safety has to take place in engineering, not in project management. But basically, all the processes are affected. And all processes are somehow in charge to limit the risk that the people are harmed by a car, or by finally a fault occurs in electronics or software inside the car. Yeah, I already told you that everything is somehow about faults. So kind of picture what that means. Of course, faults could occur and failures on each level, let's say, on the E-system. It starts somewhere in the electronics, very deeply in software or hardware, and then it cascades in the general case. It cascades up to the components, to this ECU, and across the ECU, it goes into the communication system between ECUs, and then somewhen kind of cascading up of the failure and the fault, when you meet the car and something goes then wrong on the car level, which means the car does something unexpected, unforeseen, unintentional, but unintentionally happens to the car, moving, driving, braking, steering, whatever is that reaction by a fault. And of course, everybody can understand that if a car is on a certain speed, right, and it does something unexpected, of course, people can be harmed somewhere on a parking place or on the highway or whatever, right? So that is the hazard. So whatever goes wrong on the more mechanical level, you can see it like that, which is the vehicle level. That's the hazard. That is something we want to avoid. A fault itself, somewhere in the electronics, does not harm people, right? We have to avoid that the fault is cascading up to the vehicle level and is then causing that hazard, right? So we have some time and we have some opportunities to detect that fault to avoid that the hazard occurs or that the hazard becomes true. So that is somehow the basic idea of how technically can a risk be limited. That is to detect the fault as early as possible and to foresee, okay, this one can affect the car level and can affect the behavior, let's say, of the car, and that could end up in a hazard, right? So that is to distinguish from other faults, which may be just comfort things, right? My heater or my air conditioner in the car is not working. So okay, that's annoying, but it's not safety related, right? So I cannot harm people by just it's being cold in the car, right? That's not possible, not in our world. So we don't consider cases like driving with a car at the pole somewhere, right? So it's more in areas where we typically drive our cars. So that means there are cases annoying, but no hazards. And of course, electronics and software has to distinguish those cases to really know this is a fault-related or safety-related fault, and this is, just a fault. It limits my availability or the comfort or whatever. Yeah, you can see it already by everything we talked so far. It is a complex standard, right? So if it affects all the processes along the V-cycle, if it's about detecting faults in all areas like software, hardware, and so on, so that sounds a bit like, there's a lot of things they have to consider. And so, yeah, that's true. You see that big picture here, which shows kind of all the parts of the ISO standard. You see here 10 parts arranged around the 3 V-cycles. One V-cycle is the system-related V-cycle, and the little V's are software and hardware development V's, so that is what is expressed by the V-cycles. And you see different parts here. So it starts on the very top level. Part 1 is a vocabulary, it defines all the terms we use. Part 2 is the management of safety, and it goes down to systems, software, hardware, and ends up finally with the guideline across safety. Part 10, which is more kind of a guiding part. It's not really requirements providing, it's more explaining all the other 9 parts, what they mean. So if someone of you wants to start reading the ISO standard, so I would recommend to start with part 10. Don't start with part 1. It's a bit annoying to read just terms. That's the reason behind. So, and you see the numbers, right? 600 requirements, 500 pages, whatever, right? 180 engineering methods. So again, it's a complex things. And of course, maybe you see why that is consultancy business. If someone just sits down and reads all the stuff here and tries to make his own picture out of that and tries to make a process for his project out of it or his company out of it, the risk is very high that you misunderstand and that you maybe formally understand or just formally understand the ISO standard, and you end up with a bunch of bureaucracy and without any value for safety, right? Just formally doing something. So, and of course, that's why consultants are in the business. People who not only have read the standard, they know how it's applied and can support you in that. Yeah, not to forget that. Maybe for some of you already know that, and maybe waiting for some news about that. I don't know. So maybe for those of you who are more familiar with safety already, they know that since months there's a new edition announced from the ISO committee. It's still the ISO26262, but it's called the 2nd edition, or it's called the 2018 edition, which is it's obviously the 2nd edition. So what we have shown you so far is all about the 1st edition, and now we are waiting for the 2nd edition. It was announced for already March this year, and still it's not there. And we come to that at the end of this webinar in more detail, but basically the basic information here is still we're waiting for the final version. Some in-between versions are out, but the final version is still under release, so we are waiting for that version every day. But maybe to give you kind of outlook what is upcoming there in terms of new. Yeah, the most obvious things are we will have 2 new parts, so the part 11 and the part 12 are new compared to the 1st edition. The part 11 is a non-requirement part, so it's just informative. So it's a kind of addition to part 5, and it explains the safetiness or the requirements for safety engineering for the hardware level, specifically for those who are developing ASICs and different complex semiconductors or microcontrollers and stuff like that, which are really complex now and not just simple hardware parts. So they need some further explanations what is expected from the safety point of view, and that is laid down in the part 11. So it's completely out of scope for those of you who are, I don't know, in ECU business or in software business on ECU level, then you can just skip this one. But if you're in semiconductor business and you're in a company who is developing semiconductors, ASICs, whatever, then of course this one is very interesting for you. And same somehow applies for 12. Part 12 is also a very specific scope. It means it is a kind of addition of Part 3. Part 3 basically deals with the risk assessment for ECUs to find out which is the right ASIL. Maybe you have heard already of the ASIL, the Automotive Safety Integrity Level. So that is a kind of very important measure out of the safety standard. And this ASIL is somehow adapted to motorcycles or three-wheel cars, lightweight cars. They get a special ASIL to say. So to say, and that is laid down in Part 12. So it's a special risk analysis concept for smaller vehicles, right? As we find it, for instance, on the Indian market, for instance, there we have much more 3 wheels and 2 wheels cars or motorcycles than we have 4-wheel vehicles, right? And also they driving on roads and they can harm people, no doubt about that. So they have not been in the scope of the ISO so far. They are moving into the scope of ISO26262 in the 2nd edition. And also trucks will be in there then. So these are the most obvious changes. Of course, there will be much more changes on a more detailed level on each level and on each part of the ISO standard. More clarifications, more appendixes, and more methods are explained there. Most of the things we will have there is about explaining those who are reading the ISO standard more out of practice what we have learned in the last 7 or 6 years by applying the 1st edition of ISO. So it's more about that. It's not about to invent safety in a new way, right, or to present a new kind of safety. It's more explaining it better, more precise, what we really expect from the people who are developing products in the area of functional safety. Okay, yeah, not to forget that ISO is, of course, just one standard out of many we apply in the automotive industry. And just to touch a bit the liability question, which is always around with safety. So safety is not a specific standard concerning product liability. It's just one out of many. You see that kind of layered model here and on this slide. So below ISO there are other models like SPICE, or there are laws, there are lower level standards like ISO 9000 or 6949 and other standards we know also in the automobile industry. So that is not about that safety has changed something concerning liability. It's more that a safety standard ISO 26262 made it more obvious now, more clear now, what is expected as state-of-the-art of science and technology. So if some company comes into a legal case, of course, then it's more clear what is the benchmark concerning safety. It's not what other companies are doing. It's more what is written down in the ISO standard, because now the industry has a very dedicated industrial standard, and so everybody can read it. So if you like, somehow there are no excuses anymore for nobody not to regard safety in development. That's the impact of the ISO standard. It's not that liability has increased. That is always around. If your product is harming people, then you're always in a critical situation concerning liability, whatever standard is around, right? So the standard just makes transparent what is expected. And you see some examples here on the right side concerning processes and methods, what would we expect from a company who is in the functional safety business. I mentioned already the ASIL, which is a very important concept of ISO. Just a short description, right? It is all about that we have a tolerated risk level with what we accept by malfunctions in the car, and of course by people getting harmed by a car or by a fault occurs inside the car. But of course, by each new function you put in your EE system, you basically increase the risk. That's the view of ASIL. So it's not just that you put a new function in, you increase the risk by that the function goes wrong, somebody gets hurt. So what we do by safety is somehow to reduce that risk level again back to what we can accept as a kind of residual risk which should be below the tolerated risk. The calculation is quite simple, as we know it from other risk-based approaches. It is always a product out of severity and probability. If you look in more detail, then we see that probability is split up in 3 parts. One part is the E part is the exposure. That means how often is my car in such a situation then where that risk can occur. Then there's the C, the PC, which says how good is that situation controllable, and then there's the important thing, the integrity, the risk or the probability, how often my electronics and software occurs or fails, let's say, as a probability measure. So the integrity, that is what somehow is described by the ASIL. So that's the kind of assumed probability that my ECU fails. So you see, that is of course natural if you consider accepted risk, so that there is a certain probability something could go wrong. And that ASIL defines how often that can be. So if we do the risk analysis in functional safety for ECU, then we try to find out, based on situations, that means the exposure, based on assumptions about controllability, and based on the severity of a hazard, we calculate somehow based on lookup tables, nothing really calculating, it's more lookup table approach. We try to find out what is the allowed integrity in terms of probability. So how often my ECUs are allowed to fail here. And that forms the ASIL. There are ASIL A, B, C, D. Maybe some of you already heard about that. And so we have dedicated stages, just 4 stages. And all these 4 stages define somehow the kind of allowness to fail, right? So on ASIL A, I have more allowness to fail as an ECU, right? And on ASIL D, I have a limited allowness, and more quality. And so finally, everything comes down that integrity is a quality measure. So the less failures are allowed, the higher is my quality. So finally, everything comes down that ASIL is a quality measure, very much, of course, focused on faults which could end up in a hazard, of course. Yeah, that is the automotive safety integrity level, which is very important and the most important concept in an ISO. And out of those ASIL, we get a lot of recommendations and requirements out of ISO. So if you are that ASIL, then you have to do this on your product side. That's a gray box. You have to do something in terms of the increasing level of diagnostics, to implement some self-tests in certain places, to set up a good architecture which separates software components and hardware components from each other so that faults cannot cascade somehow, and stuff like that. Maybe also redundancy is a topic here. It depends on the ASIL. That's on the product side. And also we have requirements and recommendations on the process side. So to apply methods, to apply, for instance, traceability of requirements, to apply safety analysis methods like FMEA or stuff like that, but also management things like you have to have a safety plan, you have to provide a safety case, and stuff like that. That all depends on what ASIL do I have. So some of the requirements are the same for all ASILs, and some have to be distinguished. Yeah, I mentioned already that the ASIL somehow is calculated by a lookup table. So what you see here is a very simple example how that could look like. So it is a kind of table, right, where you start on the left side, or you look at one function or one feature of your car, which could be here, like here, it's a kind of braking function. And then you go through different failure modes, which means, oh, there's no braking effect, there's an unexpected braking, so suddenly the car brakes, or there's an asymmetric braking, so both wheels are braked independently and with different torques. So that could lead on, then you are in a specific situation, you're driving on high speed, above 100 kilometers per hour on the wet road or whatever, that makes your situation. And based on these informations, you take your lookup table and you think about, okay, how often I'm in such a situation like wet road and highway and driving with high speed, that is maybe the E3, which is comparable likely, let's say, in the ISO context. Then you think about how good is the situation controllable by a driver, that is the C3. So that means it's comparable hard to control that situation. And then you say, okay, what can happen? Some serious hazard can happen if you're on high speed on a wet road and no braking effect takes place. Okay, then you bump into something. So that could threat your life. High severity. And that leads to an ASIL C, this case, right? So this kind of approach You go through all your functions and you consider all your situations which make sense, and then you find out your highest ASIL for your function. And of course, not just the ASIL, it also needs a safety goal behind, which is assigned to your ASIL. So the goal says as a requirement what needs to be avoided with which level of ASIL. Also important concept in the ISO. Another important concept is, of course, the fail-safe and fail-operational concepts. That means in many cases we can afford that we just shut up our functionality in cases where we have a fault. So that's the most easiest approach for those who are caring for about functional safety. So you find some deviation in your ADC, you measure some strange values on the CAN bus or whatever, and the first thing you do is, I just shut off my ECU. I go into standby and maintain standby because my functionality is not needed for driving. It is just strange currently, and it's better to switch off, so I cannot harm anybody. Maybe I lose some functionality and lose some comfort, or I lose some whatever availability of some functionality, but I can still drive and steer and brake my car. So in those cases, fail-safe is a good concept to react on a fault in your ECU. But the more we talk about more higher sophisticated concepts we find in autonomous driving on level 3, 4, and 5, the more we cannot just switch off. I think the simple solution is, if you think about really driving autonomously on a highway, right, switching on your highway assistant and you're laying back somehow as a driver and you just look out of the window, right, and not focus on the traffic around. So suddenly your autonomous driving function is not working anymore because some fault occurs. So then fail-safe is not a good solution. So you have to go into another state, which is a fail operational state, which still allows the car to be controlled, but maybe on a lower speed, or something is limited. That is the fail operational. Or you have a second system you can just kicks in if the first system is somehow compromised. So then that is a kind of complete redundant solution. So they have a second controller or a second sensor can replace the one who has a fault. Right? That is also possible, and that somehow showed that the fail operational concept is much more complex than the fail-safe concept. It is quite easy compared to fail operational, because just switching off is more easy than to think about what could be a redundant solution for fail operational. Yeah, another big point, maybe you know that already, is traceability of requirements, right? But this picture, you see that it's not all about defining your safety goals in the risk assessment, so whatever comes out there. So you need to trace down now all your goals down your V cycle. So out of goals, we get functional safety requirements, which is a level below. Out of functional safety requirements, you get more technical safety requirements, and further on, if you would cascade more down, then we would get also software and hardware requirements, and on the right side of the V cycle we impact the test specification. So traceability of requirements is very important. It's anyway important also in non-safety areas, no doubt about that, but here you see them maybe because the ASIL is always follows the flow of requirements. There's no independent flow of ASILs independent from the requirements. So if you want to assign ASIL to something in your system, it is always done by requirements. So that means if you lose the traceability, you lose the ASIL, right? So that makes traceability of requirements so important for functional safety. And of course, that also means basically if someone says this component is an ASIL whatever, ASIL A component maybe, as an example, basically, that's wrong. There are no ASIL A components. There are only ASIL A or whatever ASIL requirements. If they are allocated to a component, then of course that component is somehow an ASIL A or whatever component. That's true. But basically, to be very precise, is the ASIL only assigned to requirements. But of course, the effect of the ASIL is then also visible on the component side. That's true, right? So it's not wrong to say this sensor is an ASIL B sensor, right? But we have to be very clear about what that really means. That means there's at least one requirement with ASIL B allocated to this sensor. Yeah, another important concept is safety analysis. along the entire V cycles, basically we have 3 levels of safety analysis. One is on system level, one is on hardware level, and one is on software level. So that means, obviously, safety analysis is a very important thing. Safety analysis maybe sounds a bit unusual or a bit high level. What does that really mean? So if you look into what is done in practice and also what is it's noted down in the ISO as kind of example, then you see that basically means FMEA as a method or FTA as a method is applied here in practice. So the failure modes effectiveness analysis, the FMEA is a well-known method already in the automobile industry. It's not new, but it's somehow emphasized, let's say, and again requested by the functional safety standard ISO26262. And same somehow applies to the FTA, the failure tree analysis is also basically known, but I don't know how often it is applied, right? You see, if you jump into the practical side of this, maybe we know these methods also in the automobile industry, but if we really apply them in all our projects, that is something I doubt. I've seen so many cases where it's not done, even if it's written in the company's processes. So safety puts a new emphasis on FMEA and FTA on system, software, and hardware level. Okay, that's so far kind of quick run through basic challenges and concept of the functional safety. Of course, it's not the complete picture about everything what is in the safety standard, because again, this many hundred pages are written about that and so on. But I think it shows the most important concepts. I hope it also shows that functional safety is not something out of the academic world, something very speculative and very high sophisticated and far away from what we are doing today in the industry. It's very close what we know, let's say, not maybe what we do, but what we know in the automobile industry. So concerning methods and what is good concerning development processes and what is good concerning to make your product reliable. So there is not really, I would not say something really new in, but by putting it into an industrial standard and really requesting it from each development project, it puts a new emphasis on things we have known before, but not really consistently applied. So it's time to have a little break, let's say, kind of, before we move on with the vector safety experience, more practical hints. I would like, if possible, to hand over to my colleague Andreas, because while I was talking about functional safety, he tried his best, and I saw him typing to answer all your questions. So I still think that there are still open questions. But anyway, I think it's time to bit summarizing maybe the 2 or 3 of the most often asked questions, so that we get a kind of feeling what is around, what are the questions around. Maybe we can help already by providing you some representative answers to that question. Maybe that helps also you before we then continue with the slides we have prepared for you. Yeah. I would then like to hand over to Andreas. Maybe he is still typing, but maybe he has a few interesting answers about a few interesting questions for you.
So, thank you, Arnulf, for this comprehensive overview. Yes, I was still answering some questions. The last one I got is concerning FMEA and FTA and how to decide where to go for FMEA and for FTA. So ISO does not tell you to explicitly use FMEA or FTAs. So it uses very general terms speaking of inductive and deductive safety analysis, but FMEA and FTA are, of course, the most prominent examples, the most favorite methods for these safety analyses. And an FMEA is sufficient a safety analysis for ASIL A and B, and starting from there, the FTA becomes highly recommended also in addition to the FMEA. So this is for one question. We got many questions concerning the second edition. If it is already released, people heard about it. I think we still have some information on this topic upcoming. As far as I can tell you already, it's not yet published. Then some people were confused because on this overview slide of ISO there was also safety of the intended functionality mentioned, the so-called SOTIF, and it was not mentioned in your presentation as far as I remember. So many people asked, what about this? Is it part of ISO also for the second edition? No, it is not part of the second edition. And then also came the question, will it be then applicable if it is not part of ISO? Maybe you remember this latte macchiato slide with all these layers talking about the state of the art of science and technology. So as soon as this SOTIF standard, even if it's not part of ISO 26262 second edition, as soon as it is published, it will become state of the art. And hence, it is expected that it is also followed and applied. And one last topic, there was also some questions on what is the relation between the HARA, the ASIL, and the safety goal. So when we use the HARA, you talk about your item and the functions, and you think what are possible malfunctions of your item. And when I'm driving around with my car under certain scenarios, driving on a highway, driving on main roads, or if I'm overtaking another car, if this malfunction happens under these circumstances, what will be the hazardous event? Will I have an accident? Will I lose control? Or will I just be confused? So this is how you get from your from your malfunction to the hazardous event, and by judging the three factors, this severity of the hazardous event, the exposure of the the frequency or duration of the possible hazardous situation, and the controllability, meaning are you still able to prevent the hazardous event from happening by using these three metrics, by these three values, you come to your ASIL determination, and then you fix a safety goal to prevent this hazardous event from happening. And so this is the relation between the ASIL, which relates to the hazardous event, and the safety goal, which is intended to prevent this hazardous event. And from there on, you derive all your functional safety requirements and so on. So, there are still more questions. Then I will give back to you, and I will continue answering these questions in the Q&A.
Yeah, thank you, Andreas. Yeah, sound there is a lot of discussion around, and yeah, all those questions, of course, making sense, right? That's because we are going very quickly through the concepts, and so the HARA, for instance, is a method, right? You have to really, you need to, let's say, experiences in applying it to really understand what's behind. So we just quickly introduce it. So that is natural that there are questions how the whole thing works and how requirements coming out of that method, how that works. So yeah. Anyway, I would propose to continue with some more practical examples out of the concepts of functional safety, how we approach those things in practice. Just a few, right? It's not a complete picture what we do or what we see from vector side and projects, how things are done, but a few things maybe helping you also to better understand the concepts of functional safety. So again, it is a life cycle thing, functional safety, and somehow that means you need a plan across your life cycle. What are my work products on each level? What do I need across the V cycles, the systems V cycle, and also hardware and software cycle, wherever you are? So I have to plan for my, so you see here a few examples of typical work products out of safety, right? Like the item definition, which is the ECU and the sensors and actuators. Then what we have already discussed about the hazard and risk analysis, that's the HARA. This is all a document, right? Also the safety concept, the validation plan, and finally what you deliver to your customer in terms of the summary of all your documents and measures you have applied for reaching or for confirming or complying to your safety goals. That is then laid down in a safety case. So all these documents, they need to be planned, and they are effort, they have requirements to fulfill, so we have to plan for it. You have to plan for not only the when and the effort, also to who's doing that and who has the right skill to do that or to create that document, because the documents are not just there. You see it by a lot of technical documents. It's not just about to write something down. It's of course to reflect what have we done on the product side, right? So it's not just about I have to write a paper called Hazard and Risk Analysis. There are requirements coming out of that. They have to be allocated to pieces of your component, or to your ECU or sensor or actuator, or whatever you are responsible for in the area of EE systems. That all the requirements are going into that. They're not going only in the process side. Again, of course, the ISO standard itself has lots of requirements from the process side. That's true, but what we do in the HARA and the safety concept and whatever, and the safety analysis, that is not just a process thing. It creates measures, mechanisms, requirements which are going into the product itself. Because, of course, what makes the car finally safe, it's not the paper outside. It is the software and electronics, how it's designed and implemented on the car. That saves lives. The paper cannot save lives, right? The paper is just a means to assure that everything is done on the product side. Okay, that is one, of course, very basic best practice out of what we have seen. Second thing is, of course, we already heard that a lot of analysis, safety analysis, has to be applied for functional safety on many levels, like system, hardware, software. You heard already about FMEA and FTA. So it sounds already, there's a bunch of documents and tools we have to apply. So you see here a picture of a vector tool, which is called Prevision, which is an integrated tool, which is a very good approach. Maybe not only true for this particular tool, in general for such integrated tools. So, of course, if you have to deal with requirements, architecture, and analysis in terms of tools and documents, that is a complex thing, right? And you have to deal with many, many different maybe documents. If you do it, for instance, with Excel, then you have a lot of spreadsheets flying around in your project representing requirements and architecture and the FMEA or whatever, right? So that makes life very hard if you have to change something, and you have to change related information in each of these documents, and it's very tough and effort-consuming, of course. So, and integrated tools help us to keep the data in one place. So if you change a requirement, then you see it immediately in the architecture, what has changed, and you can change or align your architecture according to the changed requirement. And also you see it in the FMEA. Oh, we have a new function here, so we have to cover that function by safety analysis. A few rows have to be written here concerning failure modes or whatever. So that is a big help for those who are dealing with changes in projects, and you know, changes are always on in development projects. You have maybe not in the beginning, but starting somewhere after the beginning of the project, then changes coming in, and you have to maintain your data according to those changes, and that can really kill a project, right? So that is also a more general thing. It's also helping in safety. Use sufficient appropriate tools for that. Yeah, another important thing is in practice that the ISO 26262 has no idea, let's say, or there's no definition about interfaces between companies. So there's nothing written like, oh, from the ISO point of view, the OEM has this task and the tier 1 has this task. That is, you find it nowhere in the ISO. You just find the concept of, yeah, there are different companies working on the same item. Yeah, there are interfaces between companies, that's true. And the only thing you have to do is to cover these interfaces with a document we call DIA. That's the Development Interface Agreement. I come to that in a second on the next slide, how that could look like. But that is the only approach provided by the ISO. So the ISO is not ignoring that fact, but there's not so much help how that shall be done, because consider now the case, there's an OEM has done the HARA, has found out some goals, and he provides the safety goals to his supplier, but supplier says, oh, I have a different HARA on my side. I have different goals or different ASILs, so I don't agree on on the OEM's HARA. So that needs to somehow natural conflict. So there's nothing said from the ISO point of view, but from vector point of view, we would recommend such interfaces should be not only covered by, of course, also covered by an agreement, by an interface agreement, but in addition, as much as possible, provide or perform joint workshops for the HARA, for FMEA, for FTA, to bring the people on both sides together in one session, so don't produce too many discussions and different understandings along interfaces between organizations, right? So do the things together, and that helps a lot to be efficient, and efficiency is always a measure to avoid faults on the process side, right? If it's about having lots of discussions between an OEM, for instance, and a tier one, that means sooner or later you get many changes, and that could lead to some faults. You oversee something and a changing requirement or whatever. So that is, from the safety point of view, that is also critical. So efficiency always means less faults, not so error-prone as lots of discussions going on. It's always unclear what is the current status of agreements and stuff like that. Yeah, DIA, just to give you an example how such a document looked like, is not kind of, yeah, it's not rocket science, to put it like this, right? It's a list of documents. You find here on the left side the definition of the ISO, what work products are expected by ISO. So it starts with software architectural design. You see is a very general document, also expected by ISO. Then a short explanation in the next column. And then you see two big sections. The red section, let's say here, and the blue section says, okay, this document is done with this name and this responsible person by the tier one maybe, or by one party of the interface, and the blue side is the second party of the interface. No, right, this is what we're doing, that is what you're doing, so to have an agreement who is doing which documents so that we don't miss anything, what is requested by ISO26262. And in addition, you find typically there what you find here in the column S, a kind of procedure how we deal with such documents in terms of, yeah, we provide the document as an exchanged format, so we regularly exchange documents. No, we just do a joint review on that, so it's still owned by us, but you can review it, or it's just shown in the audit or whatever, right? So that it can also be defined here. That's not so much ISO related, it's a more kind of best practice, that this is not only defining the names of documents, fulfilling ISO requirements, it also defines kind of how we deal with those requirements, who is doing what with these requirements on both sides. Okay. Yeah, not to forget that, assessments and audits is a topic in ISO. We haven't mentioned that so far. It's just mentioned here because, yeah, somehow we know audit and assessment, they are also applied in other areas. So like if you implement SPICE, for instance, in your process environments, then of course you also get an audit if along the SPICE process areas and requirements, if everything is fulfilled there. Or you get an audit according ISO 9001 or whatever, right? That concept is known. But maybe we need to a bit explain it in the light of functional safety. So safety says, safety audit is something you have to do for your processes, and safety assessment is something you has to be applied. But that's the more heavyweight approach, because an assessment means reviewing and analyzing the processes as well as the product itself. So if you look on both sides in the audit, you just look on the process side. But that's the good news is both approaches are only expected if your highest ASIL is higher than B. So that means ASIL C and D. Again, the ISO standard does not say who is doing that, just says it just defines sufficient independency of those who are conducting audits and assessments. So that needs to be considered. So it's not said that it's always an external person. It just means it has to be sufficiently independent from the project who has developed a certain product. But that is an important point. You have to consider that. And it is, of course, kind of it explains on the other hand also that there is no real certification expected by ISO. That is sometimes a rumor we hear in the industry, that people who are new to safety say, okay, I need a certificate for my product or for my process according to safety. No, just audits and assessments are expected by people who are capable enough to understand what has been developed and who have experiences in functional safety, that they can do the assessment or audit. That's the only expectation, and of course the independency. But that is not a certificate. It's just, as I said, an audit or assessment. So for really releasing your product, which is on ASIL C or D, you have to do an assessment. Finally, at least one. But that is not a certification. You do not get a kind of certificate or stamp on it. It's just assessment, right? And according to the requirements of ISO, somebody sits down or a team sits down and checks all the requirements from ISO if they are fulfilled by your component or your ECU, whatever you are responsible for. So that is expected, but there's no certificate for that. Maybe one of the last statements according practical experiences, I mentioned it already in the beginning. Security always comes up if safety comes up. So let's say since a few years. In the beginning it was very much separated, but the more we have connected cars, and it's growing more and more that we have somehow, it starts already with Bluetooth, right, to my app on my phone, and it goes further with wireless LAN, which is around my car, and I can use my car as a hotspot, and it ends up with the on the OTA features, the over-the-air update software on our car. So that's the thing. It's currently growing, and it's already developed for many cars, and it's piece per piece coming into the car. So that makes security a more and more growing thing, because now the attack surface of the car is growing, right? Because more and more connectivity points are at the car. So that means security comes up. So we could keep it separate from safety, because it's another thing, right? How much my car is threatened by security attacks. But of course, if you attack a car, you could also, if you are, let's say, found a way into a car by whatever kind of vulnerability, then you can also tamper or manipulate safety-related functions. So, for instance, the steering ECU or the braking ECU, right? And then, of course, you enter the area of safety. So that is one of the reasons why safety and security are always named together more and more, because they have a strong relationship on the negative side, of course, right? In terms of we try to avoid that impact of security into functional safety, for sure. But yeah, to avoid that, both topics are moving together, right? And in one spot. And of course, the methods again. So you see here already some standards have already started to be written. There's nothing like the ISO standard for safety in place now for security. So we are still working. The industry is still working on standards, but we see already a few things which are already clear, let's say. So threat and risk analysis. That sounds very much like hazard analysis and risk assessment, as they have seen it before as the HARA. So it seems that also the security is following the same approach, analyzing your risk, deriving requirements out of your risk, and then following by traceability your requirements down to whatever you implement in terms of software and hardware. So the security approach is very close to the safety approach. So that's the second reason why safety and security are more and more named together as a kind of very closely related topic. But we have to be very clear here, they are not on the same level. Safety is much more mature because they are release standards out which are required to be applied in the industry. And that's not true for security. There we have a more blurry situation. So a few papers are written, a few in-between versions of standards are out, but there's nothing out in terms of yes, that is a released and published version of an industry standard. Okay, a bit conclusion and also a bit outlook. To start in the very beginning, it is all about growing complexity, more and more functionality, that it drives a lot of problems, let's say. Also, it drives a lot of interesting things on the other side, that's true. But from safety point of view, we look more to the problematic point of we look more from the problematic point of view. So we see by growing functional complexity, many companies are a bit overwhelmed by what has to be done in terms of methods and what has to be assured, what tools have to be used, what method has to be applied. That is really driving companies, bigger companies and smaller companies. Whatever you do, also if you just produce a sensor for whatever kind of ECU in the car, then you are affected by functional safety, because the sensor is, of course, a piece of hardware, piece of software on it, so you are in the light of functional safety, right? Yeah, so that is something you have to care for, independent audits and assessments, of course. Of course, not to forget that, it's not just a standard out. More and more you get also components, products out of the safety area, like special microcontrollers which are maybe called safety controller or something like that. They provide special safety mechanisms. You get software like you get it from Vector, like the Safe Autosar. So you get more and more also components you buy some safety with, right? But it's of course, you cannot free yourself from following the ISO just by buying a piece of software, right? Not to put it like this. But of course, it helps you to fulfill function safety if you buy components for your ECU, hardware and software components which are already providing you a quantity of functional safety. There's no doubt about that. Yeah, but still we see also in industry, lots of things have to be explained. Still we are running trainings and workshops at customer sites to explain what is ISO 26262, of course more detailed like we did it here today, and to show it practically in the working environments of those companies, what that change would mean for them. So still, after many years, I mean, while we know the ISO, it's still that we have lots of companies, typically on tier 2 and tier 3 level, which have no idea about functional safety and still asking, okay, what is my task here in that game, right? So there's a lot of improvement have to be done, and yeah, it's something which drives our business. And of course, not to forget that by all the changes I mentioned in the very beginning, electrical driving, connectivity, ADAS, we get also more and more new companies in which are coming from different areas of electronics and software, non-automotive areas, which who enter the automotive industry, and of course they also need help to understand what is here different to my maybe custom electronics area I know from my other products. So there's a lot of differences, and ISO 26262 is one of the biggest differences here. Okay, yeah, a few last words. I think lots of things have been said already to the second edition, right? You see it by the timeline here. It's again postponed, so it's postponed in the second or third time already. We are waiting for the new version every day, right? We have seen a few in-between versions. They have shown us, again, no significant changes, but there are some chapters have been removed in between, then they showed up again in the next version. We have a lot of appendices in the ISO standards, like new methods which are not required but should help to better understand in the area, for instance, of safety analysis. We have a lot of new or better explained methods, maybe not new, but better explained methods there we find there. So there is not just kind of a few more notes in it. There are some new chapters we haven't seen before, but they don't change the meaning of the ISO. They provide more opportunities how it can be applied, like DFA, dependent failure analysis, and FMEA and FDA. There are more and more supports you find in the ISO standards, how it can be applied, how it can be efficiently applied, right? Not just applied. So you see there's a lot of interesting stuff upcoming, but no one dares currently to say what exactly is in, because the in-between versions have changed from one version to the other. So, of course, the working group who's working on the final version, who has worked on the final version, they know what's in, but outside that working group, we have to be careful to announce something outside. We have simply to wait until we get the final version, right? And then we will know on each level of detail what has changed. The most obvious changes have been already mentioned here. Yeah, last slide according what is ongoing on Vector side, right? Just to let you know, of course, who is interested in having more detailed information about functional safety, you can join our trainings, Functional Safety with ISO 26262. They are here located, or they are conducted here at Stuttgart site. But also, if you have a few more people in your company want to join that training, we can do that also on your side. Typically, it's a 3-day training. You find all the details, of course, if you follow the links here. There is a congress upcoming, the Vector Congress, here in Stuttgart. It's called In Sync with Tomorrow's Mobility. You see, it's about the new topics I already mentioned: autonomous, electrical driving, connectivity, and things, and the impact, of course, on electronics and software, right? It's not the high-level discussion. It's, of course, because it's a Vector Congress, it's about software and electronics and what it means to us, right? So you're invited to that. And, of course, we will have more webinars. The next upcoming webinar will be about automotive cybersecurity, right? As I mentioned, yes, it is closely related to safety, but there are a few things special to cybersecurity in the automobile industry, so it makes sense to let you know what's out there and what's new there. So you're also invited to that. Okay. that's it so far. Thank everybody for listening to us and joining us. And if you wait for your answers concerning your questions, stay tuned, because Andreas is still answering questions, so you will get your answer. Latest tomorrow, if not today, then you will get it tomorrow. So we try to answer every question if we can, right? So thank you very much for being here, and hope to see you again in one of our next webinars.